By the way, astronomical occasions of remarkable scale take place billions of kilometers away from Earth, resounding throughout the universe. Currently, a similar event is coming near, causing shock even amongst researchers. A crimson massive megastar, organized at the outer spans of our system, is speaking unpropitious signs and symptoms throughout the universe. Caught by the James Webb Space Telescope, cosmologists have uncovered deeply disrupting discoveries about this epic heavenly frame. As diagnosed astrophysicist Brian Cox offers a grave admonition, an urgent query emerges. Are we wavering on the threshold of seeing a disastrous cosmic explosion that could forever alter the natural night sky? Before digging into more info, ensure to join our channel if you haven't already. Now the burning question waits. Will this blast impact Earth, and will it be visible from our planet? Stay tuned as we inspect the answers to these compelling inquiries in this video. Within the vast span of the universe, where the show of heavenly birth, existence, and dying unfolds in entrancing marvel, one unique star has recently drawn the attention and concern of both cosmologists and the public. This star, called Betelgeuse, stands out as a red supermassive giant in the constellation Orion, flaunting gigantic size and age. Its striking ruddy color and fluctuating brilliance have long intrigued onlookers. Current events have further heightened interest in this heavenly behemoth. As we dig into the essence of Betelgeuse, we find ourselves nearing the very edge of a potentially stupendous event in the star's life cycle. But what do these changes in Betelgeuse's behavior imply? Might we witness the beginning of a grandiose display of unimaginable magnitude? Betelgeuse, flaunting a size roughly 1,000 times greater than our Sun, remains a gigantic giant among stars. Its sheer size stretches the boundaries of human imagination. Picture a star so large that, if it replaced the Sun, its surface would extend past Mars' orbit, encompassing Mercury, Venus, Earth, and Mars within its heavenly grasp. This phenomenal size not only highlights Betelgeuse's physical monstrosity, but also signals its stage in the stellar life cycle. As a red supergiant, Betelgeuse is in the sunset phase of its life, marked by expansion and cooling after a lifetime of fusing hydrogen into helium at its core. Questions arise about Betelgeuse's age. Despite being relatively young in human terms, estimated at around 8.5 to 8.8 million years old, it is quite aged in the context of stellar lifespans. Its current status as a red supergiant reflects the culmination of millions of years of stellar evolution, characterized by tremendous transformations from a hot blue star to the notable red giant we observe today. The journey of stars like Betelgeuse unfolds as a tale of constant transformation, driven by the relentless forces of nuclear fusion and gravity. One standout feature of Betelgeuse's current phase is its vivid red hue. This dark red color arises from its relatively cooler surface temperature. In contrast to stars like our Sun, shining at around 5,500 Kelvin, Betelgeuse's surface begins at approximately 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light in shades of red. But this coloration isn't just aesthetic. It offers insight into the star's physical state and the ongoing processes inside its vast gaseous atmosphere. Adding to the intrigue surrounding Betelgeuse is its unusual color history. Historical records from Roman and Chinese sources suggest that nearly 1,000 years ago, Betelgeuse appeared yellow. It was only after the 9th century that Arabic researchers described it as red. This historical shift in color is not merely a footnote in astronomical history. It acts as a signpost in the star's transformative journey. The fluctuating brightness of Betelgeuse adds yet another layer of fascination. It acts as a semi-regular variable star, meaning its luminosity undergoes periodic variations. This dance of brightness has captivated astronomers and stargazers for centuries. Typically, Betelgeuse follows a 420-day cycle, alongside a longer 5-year cycle, cited as far back as 1836 by Sir John Herschel, and perhaps even earlier in local oral traditions. However, what truly sets Betelgeuse apart is not just its shifting brightness, but its irregularity. Unlike many stars that follow predictable patterns, Betelgeuse occasionally deviates from its normal rhythm of dimming and brightening. This irregularity points to complex and less understood processes unfolding within its immense form. Recent remarkable discoveries have captivated astronomers and stargazers globally. When Betelgeuse experienced a stunning and dramatic change, now widely known as the Great Dimming, everything began in late 2019. At that time, Betelgeuse, the red supergiant shining brightly in the night sky as a prominent part of Orion, began to undergo a mysterious dimming. The dimming was so striking that it lost luminosity at an average rate of 0.01 magnitudes per day, reaching its lowest brightness by February 2020. Betelgeuse, normally visible to the naked eye even amidst light pollution, virtually faded. Even amateur observers couldn't miss it. Yet, a critical challenge remains in observing Betelgeuse's behavior. The time conundrum. When we observe a star like Betelgeuse, we are not seeing its current state, but rather its past, due to the time it takes for light to travel to us. Located about 725 light-years away, the light we see today left the star nearly 7 centuries ago. This time delay complicates efforts to predict and track sudden changes in a star's behavior, as we're essentially witnessing events that happened in the distant past. The dimming of Betelgeuse serves as a stark reminder of the inherent complexities in cosmic observation, and the limitations of our understanding when dealing with the massive scales and time mysteries the universe contains. The fascinating journey of Betelgeuse's astronomical performance was meticulously tracked by Andrea Dupree, the director of the Center for Astrophysics at Harvard and Smithsonian. Together with her team, using the Hubble Space Telescope, they launched into a 3-year study to monitor changes in Betelgeuse's outer environment. These observations provided unprecedented insights into how a variable giant star like Betelgeuse behaves, with its usual expansions and contractions leading to brightness fluctuations. The striking sensitivity of Hubble to ultraviolet light enabled researchers to probe the layers above Betelgeuse's surface, which were partially heated by the star's turbulent convection cells. At diverse durations throughout 2019 and 2020, facilitated measurements of material motion inside Betelgeuse's outer surroundings, especially the study centered on the magnesium-2 lines inside the spectra, which provide insights into the star's atmospheric conditions. These observations discovered material traveling at speeds of around 200,000 miles per hour from Betelgeuse's surface into its outer environment. This heated and dense material eventually expanded tens of millions of miles from Betelgeuse, forming the precursor to the dust cloud responsible for the star's dimming. Dupree and her team predicted that during the 3-month event, roughly twice the usual amount of material from Betelgeuse's southern hemisphere was shed. This large mass loss is especially significant because, like all stars, Betelgeuse constantly sheds mass, but at a much higher rate than our Sun. The magnitude of this mass ejection and the ensuing dimming sparked discussions among astronomers as to whether this event could signal an imminent supernova explosion. The proximity of Betelgeuse, located roughly 725 light-years from Earth, adds to the interest. If such an explosion were to occur, it would be visible from Earth, presenting a fascinating opportunity to closely study a supernova. But the question persists. What does this dimming event suggest for Betelgeuse's future? Does it signal an upcoming supernova, or is it merely a transient phase in the star's vast and complex journey? Numerous hypotheses have been proposed to shed light on this phenomenon. One theory suggests a stage in the supernova process gaining momentum due to the growing perception that Betelgeuse is nearing the end of its life cycle. Another widely accepted hypothesis implicates dust, likely originating from the star itself, blocking our view of Betelgeuse. A third explanation tested changes in the star's photosphere, its apparent surface layer, which could affect its apparent brightness. Comprehensive analysis using various observational techniques contributed to unraveling this mystery. Spectroscopic tests confirmed a decrease in Betelgeuse's effective temperature, indicating the likelihood of a substantial dark spot on the star's surface. This idea gained support from observations revealing a temperature drop of at least 170 Kelvin during the dimming period, highlighting significant surface changes. Ultimately, the key to understanding this extraordinary phenomenon came from humanity's careful gaze into space. The Hubble Space Telescope's unique observations revealed that Betelgeuse's dimming was likely caused by a vast ejection of heated material into space. This material coalesced to form a dust cloud, blocking part of the star's surface and reducing the amount of light reaching us from Betelgeuse. The formation of the dust cloud was attributed to superheated plasma, which erupted from a massive convection cell on the star's surface and traveled through its scorching atmosphere to the cooler outer layers. After cooling, this plasma formed dust particles, resulting in a cloud that blocked light from roughly a quarter of the star's surface. Hubble's ultraviolet light spectroscopic observations, which began in January 2019, played a crucial role in reconstructing the timeline leading up to Betelgeuse's dimming. These observations detected signs of thick, heated material passing through the star's atmosphere in the months preceding the dimming event. By December 2019, other ground-based telescopes also observed the star's diminishing brightness, mainly in its southern hemisphere. Initially, this material appeared brighter than the star's usual luminosity, eventually culminating in the formation of a shadow as it scattered outward and cooled. The concept was simple. This outward flow of material and the resulting shadow were responsible for the star's sudden dimming. The scale of this ejection is truly extraordinary, pushing Betelgeuse into the cosmic spotlight. The star expelled an estimated 400 billion times the mass typically released in a standard coronal mass ejection. This expelled material was thought to be enough to offset our moon several times over, marking a major event, not just for Betelgeuse, but also for advancing our understanding of stellar mechanics. But what are the implications of such a massive release of material for Betelgeuse and broader theories of supernovae? Traditional understanding suggests that red supergiants like Betelgeuse routinely shed mass before reaching the cataclysmic peak of their lives. However, the scale of this release challenges that belief, hinting at a potentially more volatile and unpredictable final stage for such stars. Could Betelgeuse be gearing up for its grand finale, a supernova explosion within the coming centuries? Later studies speculated on the timing of such an event, suggesting it could arise sooner than previously predicted, possibly in just a few years. Additionally, the concept of the bow shock adds another important layer to the Betelgeuse puzzle. As this massive star races through space at around 67,000 miles per hour relative to its surrounding interstellar medium, it creates a bow shock, much like the wake formed by a moving boat's bow. This phenomenon arises from the star's outer layers interacting with interstellar gases and dust, offering a spectacular display of the star's dynamic behavior and its interaction with the cosmic milieu. But what about Betelgeuse's recent behavior? Its surface cooling and faded density observed following the ejection event leave the star in a disturbed state even years later. Hydrodynamic simulations suggest a link between the star's convective activity, the mass ejection, and the resulting changes in its oscillation modes. This ongoing instability raises questions about the internal processes driving these changes and their potential consequences for the star's future. Moreover, the observed mass loss rate of Betelgeuse exceeds that of many other stars, reflecting a complex interplay of internal forces. Despite this, with energy continuously dissipating through shock heating and mass ejection, Betelgeuse's rhythm is shifting. The very nature of these mass losses points to the star's dynamic and highly erratic life cycle, prompting astronomers to rethink their models of stellar evolution. The profound changes in Betelgeuse's behavior continue to spark intense debate among astronomers, who are now re-examining their understanding of the final stages of a star's life. While stars like our Sun will end their lives in a relatively calm manner, transforming into white dwarfs, Betelgeuse's immense size and unique characteristics suggest it may follow a far more violent path. As a notable massive star, it has already surpassed the size and mass required to become a white dwarf. Instead, Betelgeuse's inevitable fate seems to lie in a spectacular supernova explosion, a cataclysmic event that will leave behind a remnant core, likely a neutron star or black hole. The scale of Betelgeuse's mass loss may indicate that this transformation could occur sooner than anticipated. It is thought that red supergiants like Betelgeuse typically shed substantial mass in the years leading up to a supernova, but this most recent event, referred to as the Great Dimming, suggests that this shedding process might be more unpredictable and tumultuous than astronomers previously believed. This unpredictability has led to a heightened sense of urgency in studying Betelgeuse, as it could be one of the last remaining red supergiants that will eventually undergo such an explosive event within a human lifetime. In the future, astronomers will continue to monitor Betelgeuse closely, particularly in regard to its mass loss rate, which exceeds that of many other stars. These ongoing observations are vital in understanding how mass loss contributes to the star's final stages, and may even provide new insights into the mechanisms behind supernova explosions themselves. The fact that this process is happening relatively nearby, only 725 light-years away, gives scientists an exceptional opportunity to witness a stellar death firsthand. If and when Betelgeuse eventually explodes, it may become bright enough to be seen during the day, offering a rare and remarkable spectacle for both amateur astronomers and the general public. While scientists are still uncertain of the exact timing, this event is something that could potentially change our understanding of stellar evolution and the fate of massive stars. As technology advances, the tools at our disposal to observe stars like Betelgeuse will only improve, allowing us to unlock even more of the universe's mysteries. With each new discovery, the celestial realm becomes that much more captivating. The unfolding drama surrounding Betelgeuse serves as a reminder of how little we truly know about the final stages of massive stars. While its eventual supernova may be years, or even centuries, away, each new observation offers helpful clues about what happens in the death throes of these cosmic giants. As scientists continue to study the intricate behaviors of stars like Betelgeuse, they are forced to reconsider long-held theories about stellar evolution. The star's erratic dimming, sudden mass ejection, and unusual surface cooling all point to processes that are far more complex than previously imagined. The peculiarities of Betelgeuse's behavior may also lead to groundbreaking discoveries in other areas of astrophysics, including the study of stellar atmospheres, convection, and the interactions between stars and their surrounding environments. By analyzing the vast amounts of data gathered by instruments like the Hubble Space Telescope, astronomers hope to develop new models that can more accurately predict how other red supergiants will evolve, and what signs to look for when a supernova is imminent. While the cosmic event that Betelgeuse is heading toward is undeniably dramatic, it represents just one piece of the larger puzzle of understanding the universe's life cycle. The next few years of study could provide answers that revolutionize our comprehension of stars, their ultimate destiny, and their role in shaping the cosmos.